Configure extended access control list. Scenario 1. Addressing table. R1 with 3 interfaces. This is R1. And devices. 1 server, 2 PCs. 1 server, 2 PCs. 2 employees need access to services provided by the server. PC1 only needs FTP access, while PC2 only needs web access. Both computers need to be able to ping the server, but not each other. Okay, this is PC1 and PC2. Configure, apply, and verify an extended numbered access control list. Configure an access control list to permit FTP and ICMP from PC1 LAN. Okay, from global configuration mode on R1, enter the following command to determine the first valid number for an extended access list. Okay, global configuration mode on R1. Click on R1. Enter enable configure terminal. Global configuration mode. Access list and question mark. You can see the options. The range for standard access list and the range for extended access list. Add 100 to the command, followed by a question mark. Okay, I will choose a number for extended access list 100, space and question mark. Okay, you can deny, permit, or remark is only a comment. Okay, to permit FTP traffic, enter permit and question mark. Permit space question mark. Okay, these are the protocols. When configured and applied, this access control list should permit FTP and ICMP. ICMP is listed above. Okay, this is ICMP, but FTP is not. This is because FTP is an application layer protocol that uses TCP as the transport layer. Enter TCP to further refine the access list help. And for FTP, use TCP, transport layer protocol. TCP space question mark. You can specify a network address, a host address. Any is any source, any address, and host specifies a host address, a single host. The source address can represent a single device, such as PC1. By using the host keyword and the IP address of PC1, using the keyword any permits any host on any network. Filtering can also be done by a network address. In this case, it is any host that has an address belonging to the 172.22.34.64 prefix 27 network. Okay, look at the network address for PC1. The network address for PC1 is 172.22.34.64.27 prefix, and PC1 is the 66. Enter this network address. followed by a question mark. Okay, go to R1, specify the network address of PC1. Okay, not host address, is network address, and question mark. Okay, specify the wildcard mask or inverse mask. Okay, calculate the wildcard mask by determining the binary opposite of the 27 prefix subnet mask. Okay, 27 prefix is this. 8, 16, 24, 25, 26, 27 ones, 27 ones, and 5 zeros. In decimal is 255, 255, 255, 224. But the inverse is 27 zeros and 5 ones is the inverse. On decimal is 0, 0, 0, 31. So for 27 prefix, use the wildcard mask or inverse mask. So use 0, 0, 0, 31. Or do the following. 255 minus 255 is 0. 255 minus 255, 0. 255 minus 255, 0. 255 minus 224 is 31. This is another way to allow the wildcard. Okay. Enter the wildcard mask followed by a question mark. Okay. 31 space question mark. Okay, you can set the destination address that can be a network address or host address. Any is any destination host or any address. Equal match only packets on a given port number. Okay, this is for ports. Greater than match only packets with a greater port number. Host a single destination host, a single IP address. Lower than match only packets with a lower port number. Not equal match only packets not on a given port number. And range of ports match only packets in the range of port numbers. And configure the destination address. In this scenario, we are filtering traffic for a single destination, which is the server. Okay, only one server, only one IP address. Enter the host keyword followed by the server's IP address. Host and the server IP address. Click on R1. Host and the server IP address 172.22.34, 172.22.34.62. And question mark, space, question mark. DSCP match packets with given DSCP value equal, okay, the given port number, establish greater than greater port number, lower than lower port number, not equal, not on a given port number, precedence match packets with given precedence value, range of ports, okay, the range of port numbers. Notice that one of the options is CR, carriage return. Okay, carriage return, CR. In other words, you can press enter and the statement would permit all TCP traffic. However, we are only permitting FTP traffic. Therefore, enter the equal keyword followed by a question mark to display the available options. Then enter FTP and press enter. Okay, equal question mark, equal space question mark. You can choose FTP, is port number 21 for FTP control. Okay, use FTP. Okay, here use FTP. FTP or port 21 is the same result. I will use FTP space. Okay, enter. Enter. Okay, access list number 100 permit TCP protocol from this source. The source is this network. And the destination host is only one host, is this host address. Using port 21 or FTP port on the destination. FTP port on the destination. Okay, this is the source. This network is the source. And the destination is not the network. The destination is only the host. This is the destination. Create a second access list statement to permit ICMP, ping, etc. Traffic from PC1 to server. Note that the access list number remains the same and a specific type of ICMP traffic does not need to be specified. The same number, an extended access list number. Okay, click on R1. The same number, access-list 100, permit ICMP protocol, permit ICMP protocol, and permit ping and the source is the same, this network. The destination is the same, this server. The source is the network address. Wildcard, and the host is the same, the address of the server. Okay, that is enough. Enter. All other traffic is denied by default. Okay. At the end, there is an implicit deny IP any that will deny all traffic by default. Show access list command and verify. Okay, and show access-list. Enter. You can see the extended access list 100. This with two access control entries. Notice that the statement deny any does not appear at the end of the access list. The default execution of an access list is that if a packet does not match a statement in the access list, it is not permitted through the interface. Okay. Okay, very good. Apply the access list on the correct interface to filter traffic. From R1's perspective, the traffic that access control list 100 applies is inbound from the network connected to the gigabit Ethernet 00 interface. Okay, gigabit 00 inbound. Enter interface configuration mode and apply the access control list. Okay, you can draw an arrow Okay, and now you can see gigabit 00 on R1 inbound, gigabit 00 on R1 inbound. So that's why configure in configure terminal interface gigabit 00 IP access dash group 100 in enter. Exit. Verify the access list implementation. Ping from PC1 to server. Okay, go to PC1. Command prompt. Ping the IP address of the server. You can see 172.22.34.62. Enter. Success. Ping is permitted. Permit ICMP. Very good. Troubleshoot if necessary, and FTP from PC1 to server. The username and password are both Cisco. Okay, FTP, IP address of the server, enter. Username Cisco, password Cisco, enter. Okay, logged in, very good. The FTP prompt, very nice. Exit, quit to exit. Ping from PC1 to PC2. The destination host should be unreachable because the access control list did not explicitly permit the traffic. Okay, from PC1, ping PC2. Okay, ping the IP address of PC2, this IP, 172.22.34.98. Destination host unreachable. Okay, because the access control list did not permit that traffic. Okay, only permit from the LAN to the server for FTP, and permit ICMP from the LAN to the server. And the access control list is not specifying PC2 as the destination. Also, you can verify from PC1, try to access the, okay, open the web browser on PC1. And try to access the web service on the server, 172.22.34.62, enter. Okay, go and wait a minute. Request timeout because web is not permitted, only FTP and ICMP. Close this and configure, apply, and verify an extended named access control list. Configure an access control list to permit HTTP access and ICMP from PC to LAN. Named access control list start with the IP keyword. From global configuration mode on R1, enter the following command followed by a question mark. Okay, IP access list. Okay, go to R1, IP access dash list space question mark. You can specify if it's extended or standard. You can configure named standard and extended access control list. This access list filters both host and destination IP address. Therefore, it must be extended. Okay, select extended space. Enter HTTP underscore only is the name. For packet tracer scoring, the name is case sensitive, and the access list statements must be the correct order. Okay, use the name, specify a name for this extended access list. It's not a number, it's a name. Case sensitive HTTP underscore only. Okay, HTTP underscore only. Be careful, space. And press enter. Press enter. You are on extended access control list configuration mode. The prompt changes. You are now in extended named access control list configuration mode. All devices on the PC2 LAN need TCP access. Enter the network address followed by a question mark. Okay, the source is all the network on PC2, all this network, all devices on this network. So permit TCP protocol and the network address 172.22.34.96, 172.22.34.96 space question mark, and specify the wildcard. The prefix is 28. And 28 in decimal is 255, 255, 255, 240. An alternative way to calculate a wildcard is to subtract the subnet mask from 255, 255, 255, 255. 255 minus 255, 0. 255 minus 255, 0. 255 minus 255, 0. 255 minus 240, 15. So use this as the wildcard 00015 space. Finish the statement by specifying the server address and filtering www traffic. Okay, the destination is the host, the IP address of the server. So specify the host keyword with the IP address of the server, not the network. Use the IP address of the server. Host 172.22.34.62 space, and the port is equal to 80 or www. The port is equal to 80 or www. Use www for scoring on packet tracer. Enter. Create a second access list statement to permit ICMP ping traffic from PC2 to server. The prompt remains the same, and a specific type of ICMP traffic does not need to be specified. Okay, and permit ICMP from the network of PC2, and the destination is the server. Okay, so you can do the following. Up a row to repeat the previous command and modify. Permit ICMP protocol, the source, the LAN, the host, the IP address of the server. Enter. All other traffic is denied by default. Okay, remember there is an implicit deny IP any at the end that will block all other traffic. Exit. Okay, exit from access control list configuration mode and go to global configuration mode. Verify show access list, show and show access dash list. This is the extended access list with the name http underscore only with 2 access control entries. Apply the access control list on the correct interface to filter traffic. From R1's perspective, the traffic that access list http underscore only applies to is inbound from the network connected to the gigabit Ethernet 01 interface. Enter interface configuration mode and apply the access control list. Now, this is the source. This is the source. All this network and the destination is only the IP address of the server. And draw a row okay, so you can see gigabit 01 inbound, gigabit 01 inbound, configure terminal interface gigabit 01 IP access dash group, use the same name, case sensitive, http underscore only, enter. Oh, sorry, space inbound, enter, exit. Verify, ping from PC2 to the server, go to PC2, command prompt, ping the server, 172.22.34.62. Success. Very good. Okay, permit ICMP from the network to the server. From PC2, open a web browser and enter the IP address of the server. Go to PC2, close command prompt, click the web browser. Set the IP address of the server 172.22.34.62. Enter. Success. The web page of the server should be displayed. FTP from PC2 to the server. The connection should fail. Okay, and go to R1 and permit only www or port 80, only permit HTTP and not permit FTP. So on PC2, close the web browser, go to command prompt, up arrow and FTP to the server. Try to access the FTP service on the server. Enter. May take a while. Disconnecting from FTP server. Error opening. Timeouts. Very good. Completion 100%. Thank you very much.